Okay, here's a thought to start us off. What if, the reason things fall isn't some force pulling them, but something weirder? Something about how the universe, keeps track of itself.
You mean, could gravity be less about a pull and more about managing cosmic data?
Exactly. And that's the wild idea we're diving into today. We're looking at this proposal by physicist Melvin Vopson from the University of Portsmouth.
Right. His paper in AIP Advances is gravity evidence of a computational universe. It's suggesting gravity might not be fundamental in the way we usually think.
Yeah. So our mission, if you will, for this deep dive is to explore this idea, not just gravity, but this whole concept that the universe might be optimizing, compressing information, kind of like a computer.
And we're working from Vopson's paper itself, plus a news article that helps break it down a bit.
We'll unpack things like, what was it called? The second law of infodynamics?
That's the one. And also this idea that space-time isn't smooth, but discrete, made of little bits.
Pixels, almost.
Sort of. And how gravity might just emerge from the universe trying to be efficient with information.
Which, leads straight to that question. Are we living in some giant simulation?
It certainly nudges the needle in that direction, doesn't it?
A cosmic computer where gravity is just, a really clever bit of code. Okay, so this second law of infodynamics is central. We all know the regular second law, thermodynamics, right? Things get messier over time. Entropy increases. My desk is proof.
Mine too. But this infodynamics law, it kind of flips that for information. It suggests that information entropy, basically how disordered or random the information is in a closed system, it has to decrease or stay the same.
Decrease. So information gets more organized on its own. That feels wrong somehow.
It feels counterintuitive, absolutely.
Yeah.
Physical systems tend towards messiness, but Vopson, drawing on information theory, argues informational systems tend towards order.
Compression.
Like zipping a file on your computer.
Yeah.
Less space. Same stuff. That's a great analogy. He argues matter itself wants to arrange itself to minimize its information footprint, its description.
And this ties into that discrete spacetime idea, that space and time are made of fundamental units, each holding information. Like the universe's hard drive is granular.
That's a helpful way to think about it, yeah.
Yeah.
If space-time has these basic building blocks, then how matter is arranged on them has a certain amount of, information complexity, or entropy. Vopson's core idea is the universe naturally prefers arrangements of matter that reduce this information entropy.
But how does that become gravity? How does wanting to be informationally tidy actually pull things together? What's the link?
Well, he uses this neat thought experiment. Imagine a simple 2D grid, like our basic space-time units. Sprinkle some particles randomly.
Okay, got it.
That random state has high information entropy, right? You need a lot of data bits to say exactly where each particle is.
Sure, lots of coordinates to track.
But now, let those particles clump together, form clusters. Suddenly you need much less information to describe the system. Instead of tracking dozens of individual points, you're tracking maybe, 3 or 4 clumps.
I see. It's a simpler description, more compressed.
Exactly. And Vopson argues this clumping isn't caused by a traditional force, but by an entropic force. The universe is pushing towards states that require less information.
So gravity isn't really a pull, but more like the universe tidying up its data, moving towards simpler configurations.
That's the essence of it. He actually says this attractive force generated by the requirement to reduce the entropy of the information has all the characteristics of a gravitational force.
Wow.
And the really striking part, he shows that if you follow this logic, you can mathematically derive Newton's law of gravity.
You can derive Newton's law from information compression, the equation that runs the solar system.
That's the claim. It suggests that maybe this fundamental law is actually a consequence of the universe trying to be data efficient.
Mind blown. So, like the article mentions, a cloud of dust collapsing into a planet.
Right. Initially, it's countless particles, high information entropy. Needs lots of bits to describe. Then gravity acts, it clumps into a planet on an orbit. Much less information needed now to describe that single organized object.
So gravity is the compression algorithm.
From this perspective, yeah. It's the universe's way of running a cosmic zip command.
Okay, but this isn't the first time someone suggested gravity isn't quite what it seems, is it? Didn't someone else link it to entropy?
You're thinking of Eric Verlinde back in 2011.
Yeah.
He also proposed gravity had an entropic origin. Good point. But Vopson's approach is different in some key ways.
Right. Okay. So what's the main difference? What makes Vopson's idea new?
Well, Verlin's idea was more about space-time itself emerging from information on some kind of boundary surface. It was quite abstract. Vopson ties his theory much more directly to this second law of infodynamics and also something called the mass-energy-information equivalence principle. He's saying these are the drivers.
And didn't you say the entropy direction is flipped? That's huge, isn't it?
Crucial difference, yes. Verlin suggested gravity arose from an increase in entropy. Vopson's radical idea is that it's driven by a decrease in information entropy. That's what forces matter to clump together.
A decrease. Okay. So this isn't just about rethinking gravity on its own, then. The article hinted this could tie into bigger cosmic mysteries.
Exactly. This is where it gets really exciting, potentially. Vopson suggests that maybe things like black hole thermodynamics, or even the puzzles of dark matter and dark energy.
Whoa, really? Dark matter and dark energy?
He thinks they might be understandable through this lens of information optimization. That the gravitational attraction we see, and maybe even the stuff we don't see like dark matter, fundamentally comes from this drive to minimize information entropy in the universe.
So understanding the universe's data compression rules could be the key to unlocking its biggest secrets. That's a massive claim.
It is. Improving it is another story entirely, of course. But it definitely opens up new pathways. It could potentially link quantum mechanics, relativity, information theory, these big pillars of physics that don't always talk to each other nicely.
It's a potential bridge between fields.
Could be, yeah.
Okay, and we have to ask the big one, the simulation question. Does this make it more likely we're living inside some giant computer program?
Vopson definitely leans into that. He explicitly says something like, a possible intriguing consequence is that the universe is akin to a computational process.
So if he's right,
then yeah, the laws of physics, including gravity, might literally be lines of code. Gravity isn't some deep fabric of reality thing. It's just a very efficient subroutine for keeping the cosmic simulation running smoothly and compactly.
Wow. An algorithm for reality?
It fits with some other speculative ideas out there, like the holographic principle or multiverse theories. But again, hard evidence is the tricky part.
Okay, let's try and wrap our heads around this. Vopson's saying gravity isn't fundamental. It's an entropic force driven by a law of infodynamics. The universe wants to minimize its information content.
Right. Like a cosmic computer constantly compressing data.
And that's different from earlier ideas because he focuses on decreasing information entropy as the driver.
Correct. That decrease compels matter to organize, which we see as gravity.
And this perspective could potentially help explain huge mysteries like dark matter, dark energy, black holes, maybe even point towards a unified theory.
That's the hope, or at least the potential implication. A new framework based on information.
And yeah, it does add a bit more fuel to the "are we in a simulation" fire. Physical laws as lines of code.
It certainly makes that idea feel a little less like pure science fiction and a bit more like, well, theoretical physics anyway.
So here's the final thought to chew on. If the universe really is constantly trying to compress information, what does that mean for complexity, for us, for all the information we create?
Does complexity fight against this cosmic compression? Or is it part of it?
Maybe looking at the universe through this lens as an information processor gives us a totally new way to understand the cosmos and, yeah, our own place in it all. Something to think about.